Imagine a time before time itself. No space, no stars, no planets, not even directions like up or down. This is the greatest mystery. What existed before the universe began? Even the brightest minds can only look back so far, to the very edge of the beginning. The universe's story is the grandest ever told, a tale of energy, transformation, and gravity's patient dance. Every atom in your body, every drop of water, every ray of sunlight traces back to this one spectacular event. To understand it, we must travel back to when everything was smaller than a single dot. All the matter and energy in billions of galaxies was once squeezed into a point of unimaginable density and heat. This is the starting point of our cosmic journey. How do we know? We're cosmic detectives, using telescopes to see ancient light and studying the elements in stars and planets. We listen for the faint echoes of the universe's birth, clues that let us piece together the story of everything. By following these clues, we can tell how it all began, from a moment of pure, concentrated wonder. Let's begin our journey at the very start. We call this moment the Big Bang, but it wasn't a bang in space. It was the sudden expansion of space itself. Imagine all the energy and matter of the universe packed into a tiny, hot, dense point. In a fraction of a second, the universe expanded faster than light, an event called inflation. Like blowing up a balloon, everything moved apart as space itself stretched. The newborn universe was a chaotic soup of pure energy, too hot for particles like protons or electrons to exist. Matter and energy constantly transformed, following Einstein's famous equation, E/mc2. There were no stars or galaxies, just a brilliant uniform fog. The laws of physics were just beginning to take shape. For 380,000 years, the universe was so dense that light couldn't travel freely. Photons bounced around, trapped in a cosmic fog. But as the universe expanded, it cooled. This cooling set the stage for the next great transformation. The universe would soon become transparent, and light would finally break free. That moment changed everything. The universe was ready for its next act. The cosmic story was just beginning. As the universe expanded, it cooled, like steam escaping a pressure cooker. This cooling allowed the first building blocks of matter, protons and neutrons, to form. In the universe's first minutes, these particles fused into the nuclei of hydrogen and helium, the simplest elements. For thousands of years, the universe was a hot plasma of nuclei and free electrons, with light still trapped. But as expansion continued, temperatures dropped. About 380,000 years after the Big Bang, electrons joined nuclei to form neutral atoms, a process called recombination. Suddenly, light could travel freely for the first time. This ancient light, the cosmic microwave background, CMB, is the oldest we can see, a baby picture of the universe. The CMB reveals a nearly uniform universe, with tiny temperature fluctuations, seeds for all future galaxies and stars. These tiny differences would shape everything to come. The universe was now transparent, and the stage was set for the first stars. The cosmic fog had lifted, the universe was ready to shine. With the universe now transparent, it entered the cosmic dark ages. No stars, just vast clouds of hydrogen and helium. Gravity began its slow work, pulling denser regions of gas together. Over millions of years, these clumps grew larger and hotter, becoming the seeds of the first stars and galaxies. When the pressure and temperature soared high enough, nuclear fusion ignited, turning gas into shining stars. The first stars, born 200–400 million years after the Big Bang, were giants, hundreds of times more massive than our sun. They burned hot and bright, ending the cosmic darkness. Their light illuminated the universe for the first time since the Big Bang's initial flash. These stars lived fast and died young, but their brief lives changed everything. They created the first heavy elements and set the stage for new generations of stars and planets. The universe was no longer dark. It was alive with light. The first cosmic beacons had appeared. The story of creation was accelerating. Stars are cosmic kitchens, fusing hydrogen into helium in their cores and releasing energy that makes them shine. As stars age and run out of hydrogen, their cores contract and heat up, fusing helium into heavier elements like carbon and oxygen. This process continues, building up layers of heavier elements, until iron forms in the core, Fusing iron consumes energy, so the star can no longer resist gravity. The core collapses, triggering a supernova explosion that outshines entire galaxies. Supernovae forge even heavier elements, gold, silver, uranium, and scatter them across space. These elements enrich clouds of gas and dust, seeding the next generation of stars and planets. Every heavy element on Earth, from iron in your blood to calcium in your bones, was made in stars and spread by supernovae. We are, quite literally, made of stardust. The universe recycles itself through stars. After a supernova, its elements mix with gas and dust to form nebulae, the birthplaces of new stars and planets. Gravity pulls material into spinning disks around young stars, called protoplanetary disks. In these disks, dust grains stick together, growing from pebbles to planetesimals, building blocks of planets. Collisions and mergers over millions of years form protoplanets. Closer to the star, rocky planets like Earth form. Farther out, gas giants like Jupiter take shape. As the young star ignites, its solar wind clears away leftover gas and dust, leaving a stable solar system. Our solar system formed this way 4.6 billion years ago. Earth is a product of cosmic recycling, built from ancient stardust shaped by gravity and orbiting a second-generation star. Planets are the universe's way of creating new worlds from old stars. The cycle of creation continues. Our solar system is part of the Milky Way, a spiral galaxy with about 200 billion stars. Our sun is just one star among billions, orbiting in a spiral arm far from the galactic center. The Milky Way is a dynamic city of stars, with new stars born in nebulae and old stars dying in supernovae. At its center lies a supermassive black hole, Sagittarius A*, anchoring the galaxy with its immense gravity. But the Milky Way is just one of at least 2 trillion galaxies in the observable universe. Galaxies come in many shapes, spiral, elliptical, irregular, and are grouped into clusters and superclusters. These clusters form a vast cosmic web, the grandest structure in nature. Our galaxy is just a tiny part of this immense tapestry. The universe is a network of galaxies, bound together by gravity and shaped over billions of years. We are citizens of a vast cosmic city. In the universe, gravity sometimes becomes so powerful it creates black holes, regions where nothing, not even light, can escape. Black holes form when massive stars die and their cores collapse into a point of infinite density, a singularity. The boundary around a black hole is the event horizon, the point of no return. For a black hole the mass of our sun, the event horizon is just a few kilometers wide. For supermassive black holes, it can be larger than our solar system. Near the event horizon, space and time are warped in ways we're only beginning to understand. Black holes aren't cosmic vacuum cleaners. They obey the same laws of gravity as everything else. If our sun became a black hole, Earth would keep orbiting as usual unless we got too close. We detect black holes by their effects on nearby stars and gas, not by seeing them directly. They are reminders of the universe's extremes, where our understanding of physics is pushed to its limits. Black holes are both mysterious and essential to the cosmic story. They show us how much we still have to learn. From a single, hot, dense point to a vast web of galaxies, the universe's story is one of transformation. We live on a small planet orbiting an ordinary star in a typical galaxy, but our atoms were forged in ancient stars. When you look at the night sky, you're looking back in time. Some starlight has traveled billions of years to reach you. The carbon in your DNA, the calcium in your bones, the iron in your blood, all are stardust. You are not just in the universe is in you. We are the cosmos made conscious, a way for the universe to know itself. Keep looking up, keep asking questions. The universe is full of mysteries waiting to be solved. What is dark matter? What is dark energy? Are we alone? These questions drive our curiosity. The story of the cosmos is the ultimate adventure, and you are part of it. The universe is still unfolding, and its next chapter includes you. The journey continues.